the hertz is the unit of frequency in the International System of Units. It is defined as 1 cycle per second. One of its most common uses is the description of the sine wave, particularly those used in radio and audio applications, such as the frequency of musical tones. The unit is named for Heinrich Rudolf Hertz, who was the first to conclusively prove the existence of electromagnetic waves. Definition: the hertz is equivalent to cycles per second. In defining the second, the International Committee for Weights and Measures declared that the standard to be employed is the transition between the hyperfine levels φ equals A4, Ma equals A0 and φ equals A3, Ma equals A0 of the ground state 2s1/2 of the cesium-133 atom, unperturbed by external fields, and that the frequency of this transition is assigned the value 9A192A631A770 Hz, thereby effectively defining the hertz and the seconds simultaneously. In English, hertz is also used as the plural form. As an SI unit, hertz can be prefixed. Commonly used multiples are kilohertz, megahertz, GHz and THz. 1 Hz simply means 1 cycle per second. 100 Hz means 100 cycles per second, and so on. The unit may be applied to any periodic event. For example, a clock might be said to tick at 1 Hz, or a human heart might be said to beat at 1.2 Hz. The frequency, or activity of aperiodic or stochastic events, such as radioactive decay, is expressed in becquerels, not hertz. Even though angular velocity, angular frequency and the unit hertz all have the dimension 1 per second, angular velocity and angular frequency are not expressed in hertz, but rather in an appropriate angular unit such as radians per second. Thus a disk rotating at 60 revolutions per minute is said to be rotating at either 2 a radian per second or 1 Hz, where the former measures the angular velocity and the latter reflects the number of complete revolutions per second. The conversion between a frequency f measured in hertz and an angular velocity I per mil measured in radians per second is, and. This SI unit is named after Heinrich Hertz. As with every international system of units unit whose name is derived from the proper name of a person, the first letter of its symbol is uppercase. However, when an SI unit is spelled out in English, it should always begin with a lowercase letter, except in a situation where any word in that position would be capitalized, such as at the beginning of a sentence or in capitalized material such as a title. Note that degree Celsius conforms to this rule because the d is lowercase a are based on the International System of Units, section 5.2. History: the Hertz is named after the German physicist Heinrich Hertz, who made important scientific contributions to the study of electromagnetism. The name was established by the International Electrotechnical Commission in 1930. It was adopted by the General Conference on Weights and Measures in 1960, replacing the previous name for the unit, cycles per second, along with its related multiples, primarily kilocycles per second and megacycles per second, and occasionally kilomegacycles per second. The term cycles per second was largely replaced by hertz by the 1970s. Applications: vibration. Sound is a traveling longitudinal wave which is an oscillation of pressure. Humans perceive frequency of sound waves as pitch. Each musical note corresponds to a particular frequency which can be measured in hertz. An infant's ear is able to perceive frequencies ranging from 20 Hz to 20,000 Hz. The average adult human can hear sounds between 20 Hz and 16,000 Hz. The range of ultrasound, high-intensity infrasound and other physical vibrations such as molecular vibrations extends into the megahertz range and well beyond. Electromagnetic radiation. Electromagnetic radiation is often described by its frequency the number of oscillations of the perpendicular electric and magnetic fields per second expressed in hertz. Radio frequency radiation is usually measured in kilohertz, megahertz, or gigahertz. Light is electromagnetic radiation that is even higher in frequency, and has frequencies in the range of tens to thousands of terahertz. Electromagnetic radiation with frequencies in the low terahertz range is often called terahertz radiation. Even higher frequencies exist, such as that of gamma rays, which can be measured in kilohertz. In computers, most central processing units are labeled in terms of their clock rate expressed in megahertz or gigahertz. This number refers to the frequency of the CPU's master clock signal. This signal is a square wave, which is an electrical voltage that switches between low and high values at regular intervals. Hertz has become the primary unit of measurement accepted by the general populace to determine the performance of a CPU, but many experts have criticized this approach, which they claim is an easily manipulable benchmark. For home-based personal computers, CPU clock speeds have ranged from approximately 1 MHz in the late 1970s to up to 6 GHz in IBM Power processors. Various computer buses, such as the front-side bus connecting the CPU and Northbridge, also operate at various frequencies in the megahertz range. SI multiples, higher frequencies than the International System of Units provides prefixes for, are believed to occur naturally in the frequencies of the quantum mechanical vibrations of high energy, or, equivalently, massive particles, although these are not directly observable and must be inferred from their interactions with other phenomena. For practical reasons, these are typically not expressed in hertz, but in terms of the equivalent quantum energy, which is proportional to the frequency by the factor of Planck's constant. See also Notes and references. External links, BIPM cesium-ion FCS definition, National Research Council of Canada, Cesium Fountain Clock, National Physical Laboratory, Trapped Ion Optical Frequency Standards, National Research Council of Canada, Optical Frequency Standard based on a single trapped ion, National Research Council of Canada, Optical Frequency Comb.